have done already chemistry MCQ. So what did you feel about it? Answers, were you comfortable with it? See, basically I gave you the questions from the portion which we have covered. That was the thing, and we have taken very basic things because for your all the examinations you have all basic chemistry which is going to be there, your 11th, 12th and BSc level syllabus. So let's discuss the answers. So you have got the sheets. So first question is, which of the following shows positive inductive effect? So answer for this is your D part. D part, see, NO2, Cl, COH, all are electron withdrawing groups. Okay, all are electron withdrawing groups. And your CH3 group, which is their methyl, that is electron releasing group. So that's why this is the example of D is the right answer. That is, this is methyl is showing, will be showing positive inductive effect. Is it clear? Okay, let's go to the next one. Which of the following group shows negative inductive effect? So I think when we talk of negative inductive effect, we need to see which are the electron withdrawing groups. We have to differentiate between two types of groups. One is electron withdrawing group, another is electron donating groups. So please remember, electron withdrawing groups which are there, they show negative inductive effect, and electron donating group, they show positive inductive effect. So now if we see this is ethyl, this is your tertiary group, this is phenyl and this is methyl. So what is the right answer according to you people? Yeah, yesterday that day we had discussed about it, that phenyl is the right answer. So answer C is the correct one. Now let's go to the third question. Which of the following is most stable carbocation? I hope you remember that. Which is the most stable when we compare primary, secondary, tertiary? Tertiary is the most stable. So see this, so in this case, which is the tertiary one? B is the tertiary carbocation or carbonium ion. So B is the right answer. Okay. Then everybody is clear about it now? Primary, secondary, tertiary. Okay. And which of the following is least stable carbocation? Now out of this, methyl, ethyl, tertiary butyl and isopropyl, which is going to be the right answer? Ethyl, methyl, louder. Methyl is the right answer, that this is the least stable. But do you know what is this isopropyl group? See, in case it was not asked here, methyl was not given, then what would you have done? Ethyl. Right? But what is this isopropyl group? Any idea? Isopropyl is, propyl is 3 carbons. This is what is isopropyl chloride. Fine. This is isopropyl chloride. So in this case, the carbonium ion which will be formed from this, that would be, क्या हो जाएगा वो? That would be, what kind it is? Primary, secondary, tertiary? Secondary. So from here you are getting a 2 degree. Now do you know what is tertiary butyl? The structure? See, all of you know tertiary it is. This is the same thing which we had been talking. See, butyl means 4 carbon atom. Already 4 carbon atoms are there. So from here you are going to get a carbonium ion. This is your 3 degree carbon. Is it clear now? So in this case, the least stable is going to be your methyl group. Methyl will be the least stable carbocation. Now let's go to the next one. Which of the following has longest bond length? So in this case our answer is going to be HI, longest bond length. See, what examples we have taken? Fluorine, chlorine, bromine, iodine. That is, we are going down the group. Group में नीचे जा रहे हैं ना, we are going down the group. So as we are going down the group, the size of the atom increases, isn't it? Size increases. So our bond length is going to be, and our electronegativity also decreases. Maximum electronegativity is of fluorine, isn't it? If we compare fluorine, chlorine, bromine, iodine, so which element is having highest electronegativity? Fluorine. So that way this bond will be the shortest. So your question can be asked in another way also, that which of the following has the shortest bond length. Clear? So this way also your question can be. Then I think your answer will be HF. But now your answer is C, that is HI. Now let's go to the next question. The displacement of electrons in a multiple bond in the presence of attacking reagent is called, it is in electromeric effect. यहाँ पे A is missing here, but your answer is electromeric effect. So should I need to repeat, or electromeric effect is clear to you? No problems? Okay. See, if it had been elimination reaction, if we are using strong alcohol KOH, so what base? So what will happen is, when it will undergo elimination reaction, you will get CH2 double bond CH2, and your minus HCl would be eliminated. Is it clear? That is, if it is an elimination reaction, then see how we write down this is C. So in this case what will happen is, that is Cl goes from here, H goes from here, and you are going to get this double bond here. Is it clear? So then it is elimination. But in this case it is your substitution only, because Cl is being replaced by or substituted by OH. Now the question comes is whether it is an electrophilic or a nucleophilic reaction. See, now what you have to see is, whenever such reaction is there, you have to see that what is the attacking reagent. KOH is the attacking reagent. So if you see KOH, that means K plus and OH minus. If OH minus is there, that means it's a nucleophile, isn't it? That's a nucleophile. So that's why it is a nucleophilic substitution reaction. Is it clear? And if it had been some electrophilic, example of electrophilic you can take it. Yesterday I had talked, in the lecture I had talked about it, that we carry out nitration of benzene, for example. So there I told you it was NO2 plus, positively charged species, or in Friedel-Crafts reaction we are taking alkylation, acylation. There it is an electrophile which is working, that is a positively charged species, fine, or electron deficient species. This is clear? This question answer is clear now? Okay. I know you have, because in last these 2-3 years you have not studied much of chemistry first year, so all these are, you just have to revise all these things. Which of the following series contain only nucleophiles? So which is the answer? See here, if you see water, if H3O plus is coming, that is electrophile has come. Even what is SO3? SO3 is an electrophile or a nucleophile? SO3 क्या है? Nucleophile. How many of you say nucleophile? See, please be confident about your answers. अभी तो बोलोगे, पर एग्जाम में तो अपने आप करना है. Nucleophile. What about others? Electrophile or no comments? Nucleophile, most of you. Anyone who is in favor of electrophile? Only one. Okay, what is the basis for saying it as nucleophile? Where are the lone pair of electrons? On which atom? There are two elements here, sulfur and oxygen. So on which you are having lone pair of electrons? Oxygen you have. See, sulfur trioxide is this. This is what is sulfur trioxide. And please do remember, sulfur trioxide is an electrophile. Okay, it is an electrophile, and reason I am telling you why. See, here you can see, you at sulfur you have all three triple bonds, but an oxygen you are saying lone pair are on the oxygen, but is oxygen attacking the molecule? No, it is the sulfur part which is attacking, and when the resonance takes place, this is in this direction, your sulfur achieves a positive charge here, oxygen is negative here, right? And this is a resonance stabilized structure, that is next, this will go back, here it will be like this, it's a resonance stabilized structure. Same way we will have a third structure, it is a resonance hybrid structure, fine. So here it is, sulfur is basically positive charge, so SO3 is an electrophile. So I hope now it is clear to you that just looking at this. Now let's talk about, so this is clear, we have two electrophiles, we can't take it. Now ammonia, water and ROH, these all three are nucleophiles. So your correct answer is B. See here, that way that would have been a confusion for you. If you see the D part, cyanide, OH minus, SO3. If you would have considered SO3 also nucleophile, then you would have been confused between these two. Are you getting this point? That's why I have given this option SO3 here also, so that you are clear about it, that it is an electrophile. So your here I think AlCl3, I told you that all Lewis acids are electrophiles. Clear? So this is clear to you. Now let's go to the next one. Which of the following pairs represent only electrophiles? What is the answer for this? A, B, C, D. Which one? Electrophile. यहाँ तो दिख गया हमें negative charge. We can see here. This is not possible. Sometimes you have to rule out also few things. Wherever, see, when you are giving an exam, then if you are not able to get the right answer, then you start ruling out things. Here you can see, here it is OH minus. That means this option is ruled out, and ROH we know also. Here water we are sure about it. Fine. So this is not possible. Here NO2 plus and NH2. You have a positive charge, and what about NH2? On nitrogen you have, when NH2 is there, remember ammonia, that just one H is being replaced by R group. Fine. So therefore in this case you have a lone pair. So it is going to act as a nucleophile. Now we are left with this. Cl plus is definitely an electrophile, and BF3 again a Lewis acid, it is a electron deficient species. So that's why your correct answer is the A. Next question. Which of the following sets of compounds is in the same homologous series? So I think this you can C is the right answer, because homologous series, when you talk about it, then it is just addition of which group? Homologous series, methane, ethane, propane. What is the difference between them? One CH2 group difference is there. So if you see the C part, see CH3Cl, CH3Cl is there. Now when the next series would be, that would be CH3CH2Cl, that would be C2H5Cl. Now the next will be CH3, one more CH2, keep on adding one more CH2. What it will be? C3H711. You are getting the series? Third one. Okay. So that way when you still add 2 more CH2s, you will get C5H11Cl. And do remember, see, otherwise also if you see here the functional group is not same. Fine? If you see here, now in this case also if you see ester is coming into picture. And this again not the molecule, ketone as well as alcohol also. But again in some cases there may be confusion, then you count the number of carbon atoms also, but the functional group should remain same. See, in homologous series you have to take into consideration, first part is the functional group. That is, the functional group is same, then in series you have to add one CH2 group, you keep on adding. Okay? So your third is the right answer. Now which is the stronger base of the following? Which is the stronger? Methylamine, ammonia, dimethylamine, ethylamine, base. We discussed about the basicity of. Very good. C is the right answer. But anyone who is not clear, please let me know. I can explain it again. See, I got answer from few students only, but I want that all of you should know the concept. Anyone who is not clear about the basicity of amines, we can discuss it. Just 1 minute we will take to discuss. You are not clear. Okay. अभी धीरे-धीरे आ रहा है. So see, please remember that when you are sitting in a class and at present, what is your purpose to attend this workshop? Please remember that. You are also spending time, we are also spending time. So when you go out of this place, all the concepts which we are teaching you should be crystal clear to you people. If it is not clear, please raise your hands. We are ready to, I am ready to repeat it. Okay. Now see, regarding the basicity of amines, we had discussed that base, how you are saying is, that is a species. See, when we talk of NaOH, everybody remembers. That is Na plus and OH minus, it's a base. KOH, it's a base. NH4OH, it's a base. Okay, we know OH minus species is being liberated. Fine. That is NaOH, when it is being ionized, that will give you Na plus and OH minus. As soon as we see OH minus, we say it's a base. That's a clear. But the problem comes is when we see the species of this kind. For example, if I take ammonia. Now in ammonia, you have one lone pair. Fine. Ammonia can form 3 bonds and it is having one lone pair of electrons. So now this ammonia is easily able to donate its electron to other species. That's why we call it as a base. That's why an aqueous solution of this. See, when it is a concentrated solution, we are saying it is liquor ammonia. But when aqueous solution is there, what you get is NH4, isn't it? I think you must have seen in laboratory, chemistry lab reagents, I think it's always written, this is one of the bench reagent which is there. So NH4OH, this is a basic in solution. Now the basic strength, when we are saying that it is a base and it is donating electrons, the basic strength increases when more and more electron donating groups are present on it. For example, now if this one of the H which is there, that is replaced by a R group, that is an alkyl group. Okay. Now this alkyl group, this may be CH3, C2, H5, any of these alkyl. So this is an electron releasing group. Already you have a lone pair of electrons on this and you have another electron releasing group present here. So basicity of this compound increases as compared to this. So this will be more basic as compared to this one. Now in this case what we have taken is, we have taken 2 alkyl groups on nitrogen. Isn't it? Here we had, just let me write down, let us compare this. Ammonia, then we have one H is being replaced by CH3, another H is also replaced by methyl group. So this is dimethylamine which is there. So now here we have 2 electron releasing group. So this lone pair giving tendency increases. Okay, so that's why basicity, this is the most, okay, basicity of this amine increases. And when we have, see, now if I compare this and this compound, CH3, CH2, NH2. This is methyl, this is ethyl. So according to the inductive effect, this is electron releasing group. So you have, it increases, the basicity will increase. But now if I compare this with this, now on nitrogen if I compare this compound and this compound, ethylamine and dimethylamine, here on nitrogen you have 2 hydrogens and 1 alkyl group. 2 hydrogens and 1 alkyl group, whereas in this case you have 1 hydrogen and 2 alkyl. So this is a stronger base. Is it clear to everyone? Now the concept is clear. But now if I take aniline and if I compare it with aliphatic amine, this will be less basic. Reason is because the lone pairs which are there, they get involved themselves in the resonance with the phenyl ring. Phenyl group is electron withdrawing group, so it starts withdrawing electrons and you have the resonance structures which are there. Clear? So that way what will happen is, now when we are taking this bond will remain same position. This electron movement is in this direction. Here you will get a negative charge. Here the lone pair have donated there. This will become a double bond, and since nitrogen has given its electron, you will have a positive charge on nitrogen. Clear? So now nitrogen will no longer be a basic in this case. Is it okay? And this negative charge, as we discussed yesterday when I had shown you the nitration, that delocalization of electron takes place throughout the ring, and these are all the resonance structures which are there, and stability of the molecule is because of the resonance only. Fine. So this is your answer in this case is C. Ammonia. No, what happens is, see, in this case if you see, ammonium hydroxide which is given, that ionizes into NH4 plus and final. So if you see the dissociation constant, here directly it is the NH3 direct, see this will ionize and then only it will act as a base. Are you getting this point? But ammonia directly it is having a lone pair of electron, so it can directly attack the species. Got it? So definitely this is going to be a stronger base, and this is an aqueous solution of this, so that concentration is decreased now. Got it? That is the reason behind it. Okay, now which is a stronger acid of the following? This I think is a very simple one. A, B, C, D, which option? I should get answers from everybody. See, even if you are, whatever you have tick mark, at least say that. You should be confident. See, from here, see. So speak louder so that I know that you have understood the thing. So see, I think because we have talked about it, that inductive effect, chlorine is electronegative. So that's the reason. Anyone who is not clear about it? Clear? No. How many of you are not clear? Please. So I think immediately you should say, so that we don't spend time on asking also. Okay. Here also 2-3 students are there who are not clear ki why this is the reason. See, acid character, one is able to judge by its dissociation constant. This is a weak acid. All of us know that acetic acid is a weak acid. But now, so that means the more the reaction goes forward, the stronger is the acid. Dissociation constant means if I take a dissociation constant of this, that is concentration of right hand side species divided by concentration of this. So higher is K, more the dissociation takes place, stronger is the acid. That is, if we are comparing two acids, then the acid which is having higher value of Ka will be the stronger acid. Okay. So in this case, now any factor which is helping to ionize this acid in easier way, or it's increasing its rate of dissociation, will make it a stronger acid. So as I told you that if I substitute, for example, one of the H with Cl group, right? Now this Cl which is there, that is electronegative in nature, so it tends to withdraw electrons. When it tends to withdraw electron, immediate first effect comes on the first carbon atom. So it tends to give, there is a partial movement. Now when this is behaving like this, the effect comes on this atom. Isn't it? This is the acid. So what happens is, now whenever its dissociation will take place, so what species are going to form? This is carboxylate ion plus H. This is going to be formed. Okay. So now what happens is, this H which is going, this is going as a proton. That is, it is leaving its electron. Isn't it? When this bond is formed, how this bond is formed? With help of two electrons. So when this bond is broken, as we talked about homolysis and electrolytic fission, when this bond is broken, so what is happening is, when H is going, it is leaving its electron. Fine, this is a proton which is leaving. Why it is leaving its electron? The reason is chlorine in. So this substitution of chlorine is making this reaction more easier, because more of this ion is being formed. Dissociation is faster in this case. Dissociation constant also increases. So now if I substitute this with another Cl, that will be much more stronger acid. Okay. But in case, now I have two species, that is here, if I have this acid and I substitute this with one. So now if I compare this acid and this one, that is, there is a difference of CH2. In this case, this will be more stronger acid. The reason is, Cl group is on the second position, the inductive effect decreases as we are moving away from the group. Clear? That day we had discussed about it, 1, 2, 3 Cl. Fine? Here when it is withdrawing, you have a partial negative charge here. Okay. And then it moves further. After second carbon atom, that diminishes. That is, that inductive effect is very less. Clear? Now it is clear or not? Clear, all of you? Okay, good. Amins? Okay, let me finish with this and then no issue. Okay, now SN1 reaction of tertiary alkyl halide proceeds in two steps. Name the type of intermediate formed in first step. I think this is a simpler one. Before we go into it, let me again revise with you SN1 and SN2. SN1 was how many step reaction? Two step reaction. And SN2 is one step. But how many molecules, rate of reaction is dependent on first step, rate determining step. Okay. So what is the intermediate formed in this case? Tertiary alkyl halide ले रहे हैं, क्या बनेगा? See, these two are ruled out. Always remember, SN1 carbocation is formed. Carbonium ion is formed in SN1. And the simple way to remember is SN1 and SN2. The most simple way, what you have to keep it in mind is, if I am taking Rx, R plus X minus. R plus plus OH minus is giving you ROH. This is your first step, this is your second step. This occurs in SN1 reaction. And now what you have to remember is, for this, let me write nucleophile here rather than writing OH. This is for SN2. Remember in a simpler fashion, and you get so this is for SN1 and this is for SN2. Here it is your two-step process in SN1, SN2 it is your, in the single step the reaction is occurring. So only thing what you have to remember is, see, in this case we had talked about it that SN1 will more favorably occur with tertiary. याद आया ना? Tertiary, secondary and then primary. Here your trend will be 3 degree. Why 3 degree tertiary? Because carbonium ion, in the first stage carbonium ion is formed. First step carbonium ion is formed. So carbonium ion will be formed in those cases only because tertiary is a more stable carbonium ion. So that's why it is here. And here it is your primary, that is your reaction order will be. So just when you are remembering, please remember briefly. Okay, just these steps, and then you remember what is this R group in SN1? It is a tertiary. What is this R group here? It is a primary. Okay, no, because see, you don't have to write down the mechanism in the exams, but your concept should be clear in your mind that these are the things. So just remember this thing, just remember this, and then remember what is R here? Primary. What is R here? It is tertiary. Because secondary also there, but I am not talking of secondary, that's in between, because all these things also depend on the concentration of nucleophile also. Concentration of nucleophile, stronger is the nucleophile concentration, more is the probability for SN2 to take place. See, जितना ज़्यादा आपका nucleophile strong होगा, वो immediately that will try to attack on this alkyl, isn't it? If you have a concentrated and a strong nucleophile, so what will happen is that immediately will tend to react with the, and then it will undergo reaction by SN2. Okay, fine. So in this case, your, what is the answer? Tertiary carbocation. Fine. And which compound will have highest dipole moment? Which compound is having highest dipole moment? CO2. Huh? Bolo. Very good. He has given the right answer. It is water. See, the reason is CO2, that day we had discussed. What is the shape? Linear. And it's on the opposite, dipoles are on the opposite side, so it cancels out. Methane, the bonds are non-polar. So polarity, whatever you are getting, it's very less. And what now we have, you must be confused between water and ammonia. But if you see the electronegativity, whose electronegativity is more? Oxygen. Period. That's why I told you, you have to remember these trends. In periodic table, please go and remember all these trends, that will help you. So in when we compare oxygen and nitrogen, electronegativity of oxygen is more. So that's why the dipole moment of water will be more as compared to ammonia. So your answer is C. Okay, I'll explain you the dipole moment also. Okay, see, dipole is a simple molecule if you consider HCl, H plus and Cl minus. That is, two poles have been generated. One is positively charged, another is negatively charged. So whenever any compound is formed, any molecule is there, you have to see the difference in the electronegativity of both the elements which are there, atoms which are forming the bond. For example, as I told you, Now let me talk about water itself. See, water, I told you we are not writing like this. We are not writing water like this. We write water like this. It's a V shape. Now the reason is that you have lone pair of electrons on the oxygen atom. And when we consider the dipole, fine. Now the oxygen is more electronegative than H, isn't it? So there will happen is your dipole which you are representing like this, that is a more electronegative element, your arrowhead is there. And here less electronegative element, you have a tail end which is there. So therefore what happens is, same with here also it's the same thing. So net dipole moment which is there, the more electron density is in this region. So it has a synergistic effect, that is in this case. Now for example, same thing it happens is ammonia also. Ammonia as such is tetrahedral and one position is occupied by this lone pair of electrons. Here also when you see the dipoles, it is like this. So that's why ammonia is also having a net dipole moment which is there. Same way that day we had talked about CH3Cl. Isn't it that we talked about it? Chlorine here. Fine. But in carbon dioxide, if you see here, which element is more electronegative, oxygen or carbon? Oxygen. So here you have to show arrowhead like this. So when you see these molecules, so it is in opposite direction. The dipoles are in opposite direction. So the net dipole moment comes out to be 0 in this case. Okay, is it clear now how we are? And okay. Now let's go to, I think this, nobody should have made a mistake in this. I had discussed this. What is the answer? Very good. It's the first one, ethyl propanoid. So specifically I kept this question because I felt I wanted to see that how many remember that. Okay, the rate law of an alkyl halide for SN2 reaction is, what is it? For SN2. Yes? Answer has to come from your side. D. Somebody said D. Very good. That's the right answer because I think SN2 mechanism just now we had written that your rate depends on the rate determining step, that you know. And in SN2 reaction, your rate is dependent on the concentration of both the species, because what was it? Our first step only, both the units are involved. In the first step only we have both the molecules involved, whereas in SN1 it was only the Rx which was involved. In SN1 it is only the Rx, that ionization. So if the question is asked for SN1, then what will be the answer? अगर यहाँ पे SN1 होता तो आंसर क्या होता तुम्हारा? हाँ? What would have been the option? B. Very good. That is, rate would have been dependent on concentration of alkyl halide only. Clear? And here the answer is D. Okay. Compare the bond length . Compare the bond length in. I want to know, somebody has given the right answer for this. We have taken into consideration this. Okay, I think from this आपके क्वेश्चन पेपर्स में होगा वन कौन सा बॉन्ड है, इट्स रिटन इन योर क्वेश्चन पेपर्स. Oh, that is missing actually. So you won't have done this. Okay, I'll ask you people. It's written there. One is your CO bond. It's written there. And this bond length is 2. It's not missing, sorry. So, what is your prediction? Answer should be which one? Louder. C is the answer. That is, you mean to say this bond length will be longer than this. What is the reason? टिक कौन सा किया है तुमने ऑप्शन है? B. So that's the right answer. Then why are you saying C? B is the right answer. C. How many of you are not clear about the answer? Okay, some of you. Okay, see, what you have to see is the bond length. Now, whenever you are considering bond length in such molecules, then you have to see that what are the atoms or the groups which are attached with it, joined to it. Now, if I see this, in this case, you can see we have to consider this CO bond and this OCH3 bond. Now, if you see this, this is already electron releasing group, CH3 is electron releasing, fine. But if you consider this carbon oxygen bond, you have a double bonded oxygen attached to it, and in this case, which is, I told you, an electron withdrawing nature. Why? I think yesterday I told you about carbonyl, that isn't it? Movement is like this, isn't it? So what happens is, this tends to pull electron towards itself. So this tends to give electrons here. Okay, this oxygen. So this attains somehow a double bonded character which is there. Okay, and this is a kind of resonance which is there. So this attains a double bond kind of structure. So that's why this bond length will be smaller as compared to this. Is it clear to everyone? Fine. थोड़ा जोर से yes बोला करो, so that I feel that you, after this MCQ, you are more clear about the things. That feeling I should also get from you people, isn't it? And then only you will be more enthusiastic to go to the next question also. Okay. Which of the following is the least soluble in water? Very simple answer. Pentanol, obvious, this is obvious actually. As your molecular weight increases, solubility decreases. So after writing down question number 17, I felt that would be a bit difficult. So I thought next I should give you an easier one. You should not feel that. Okay, now let's come back to this. SN1 reaction of an alkyl halide with an asymmetric carbon will give. This I want to see how many of you have given the right answer. Racemic mixture. All of the above. See, I had written this. See, but the reason why I had written all of the above, because I felt some people will be confused in this case. The reason is racemic mixture is the right answer. See, the reason is why all of the above is wrong, because you are not getting a single isomer. You are getting a product with opposite rotation. You are getting both. Inversion as well as, what was the other term? Retention. Very good. Inversion as well as retention. So, inversion gives you the compound with opposite configuration. Retention gives you the compound with the same configuration. That is, if I have started with a dextrorotatory compound. Now see here, why I have written an asymmetric carbon. Only an asymmetric carbon will lead to a racemic mixture. Are you getting this point? जहाँ पे जिस compound में asymmetric carbon नहीं होगा, वहाँ पे there you won't get a racemic mixture, because that compound won't be optically active. An optically active compound will only give you a racemic mixture or any other isomer, one of the isomer. So your C is the right answer. I am happy that many of you gave this answer. It's good. Okay, order of stability of free radicals is Very good. And if it had been a carbon and iron? Opposite. Primary is more than secondary, secondary is more than tertiary. Thank you very much. So all the best for your, that day I just forgot to wish you. I thought I'll be meeting you again then only. So all the best. So when is your exam now? 19, very near. So all ready for that?